Okay, so this is the bell ring for the second period, and we are moving. Okay. Right. So as I was saying, for identity matrices, if you have any other matrix that is not a square matrix, for example, a 4 by 3, that means we have 4 rows. Let's put a 1 in there. 1, 0, 0, 0. Okay. And 3 columns. So it will be 0, 0, 1, 0, 0, 1, 0. And then we have now here, I don't know if I need to put a 1 or a 0. So that is now where it becomes a problem. Okay. So this example that I gave is showing you that you will see that the diagonal is not completed, right? There's still something else here. If you put a 1 here, then it's not a diagonal. The line will go like this, okay? Like this and then down. And that is the problem. So we don't want lines that are going down. We just want numbers must be in a diagonal, means it must just be straight like that, okay? Must go like that. It must not connect to anything else at the bottom. That is basically what we call by identity matrix. And the numbers on the diagonal must all be ones, okay? All the other numbers, zeros. So identities is part of mathematics that we said that for multiplication, we have also identities. For addition, we also have identities and so forth. We did that activity in class. I don't know if you guys remember, but yeah, that's something that we're talking about here as well. And then finally, we have what we call a diagonal matrix. So diagonal matrix is slightly different from a identity. It's just that instead of us having ones, we have basically numbers. Okay, so diagonal matrix does not only have to be the main diagonal like this, and it can also go in this direction, right? So if we have numbers going this way and everywhere else is like 0, then that can also be a diagonal matrix, okay? And it must not be ones on the main diagonal. If it's here, it must not be ones. If it's ones here, then it will be identity matrix. But let me just quickly draw one for you. If it's like this, 0, 1, 1, 0, okay? This, however, is not a identity matrix, okay? Because it's not the main diagonal. Main diagonal starts with the first element in the first row, okay? That's where the main one starts. So this will just be a diagonal matrix, okay? It has ones on a diagonal, but it's not the main diagonal. So this becomes a diagonal matrix. So diagonal is just like the line that connects the corners of a matrix, okay? The 2 corners of a matrix, that line that connects it, that's our diagonal that we have, right? So continuing, matrix or operations, multiplication by a scalar. So now we are looking at multiplication by a scalar. So remember vector multiplication by a scalar. We have done this activity before, and we said that it's the same rules apply here as well, okay? Example, if for the given matrix F, find 6F, okay? So 6F is just like 6 times F, okay? Whatever the 6 is. So let's say this is matrix F, and we have to find 6F. So what we do is just say 6F is therefore equals to 6 times the 5, 6 times the minus 4, 6 times the 11, and 6 times the 3. So we said that if you have something like this, you can also write it down like this. Let me just sketch quickly. Minus 4, 3. We said that the 6 will be outside, right? And we said that if this is the case, that the 6 will multiply the first element of the the vector, that was what we said, and it will also multiply the second element of the vector. But this case, there's also other elements in, so the 6 must also multiply the other elements. So the 6 is multiplying everything inside here. So that's why we have 6 times 5. That's the one over here. We have 6 times 5. We have 6 times 11. That's the 6 times 11. It's at the bottom. And then in the next part, we have 6 times minus 4. And we have 6 times 3. Okay. So everything is being multiplied by the 6. That is now just the scalar multiplication. All right. And once we look at that, we can now just basically, after you say multiply, then 6 times 5 is 30. 6 times 11 is 66. 6 times minus 4 is minus 24. And 6 times 3 is 18. Also to note, a scalar multiplication does not change the order or the dimension of the matrix, right? It only affects the elements, okay? So the elements is the only ones that is affected, not the matrix dimension and so forth, all right? So that is one thing for us to note. So here we started off, F was a 2 by 2, okay? We still ended up with a 2 by 2, okay? That is what we have, right? So that's what we need to note about the scalar multiplication. So since we already did it with vectors, it should be easy to do it here. Now, very important to mention, when we are dealing with matrix operations, all right? There is no shortcut here. You must show all your working. It's very important to show all the working and to do all the steps. If you don't show all your working or you don't do all the steps, then it will become confusing and it will become a problem later on. So even though it is a tiring process, you have to show all of the working, okay? And that is where we will give marks from, all right? So in this case, if I had to mark, I will mark, okay, I see the working here is correct and I see the final matrix is correct, okay? So that's basically how I mark here, okay? 3 marks, that's what we will be giving you, all right? So that's very important. Is there any questions here regarding scalar multiplication of a matrix, or may I proceed? Can I proceed to the next one? We do have activities on this, so you can always attempt the activities. And then if you see you are struggling somewhere, then we can proceed. One example that I did not do is we can also have negative f, okay? Negative f just means it's f multiplied by negative 1. So this is a common thing that we will always have. So if it's negative f, that means everything inside here will just be negative 1 times 5, okay? That we put in a bracket because it's separate, negative 1 times 11. And you can see we will continue like that for everything in the matrix. And we will basically end with sort of a type of it's not an inverse, but it's also not an opposite, because that's something that we will look at later on. But all the elements inside, the signs has changed. So we will have a negative 5, we will have a positive 4, we will have a negative 11, and we will have a negative 3, okay? So that is now when we have a negative f. So you always have to also take note in that we can also use negative numbers, and then just the signs is what is going to change, and not the size of the number, okay? So it's just the signs, like the direction that we are now affecting when we are multiplying by a negative. All right, so that is basically what we are referring to by scalar multiplication. It's a very straightforward process, so we don't need to worry so much, okay? Note each element is multiplied by the scalar value. We can also multiply by a negative scalar value. That is what I've mentioned. And now we go into the second part of the operations, which is addition and subtraction. Okay, before we go there, is there any question here? Okay, I see proceed. Okay, it's fine. So let's go to that difficult. Okay, now Savoya, you have a question? Or who is this Savoya? You can ask.
So I said you can proceed.
Okay, thank you. All right, so let's look at matrix operations by addition and subtraction. So we are adding two matrices together. This is not scalar quantities. With scalars, we can only multiply, or we can try and factor out something if we need to factor out, but we can only multiply. So you can only add and subtract matrices with the same dimensions. Okay, now again, dimensions, we said it can be order, okay, it can be size, okay, so depending on what you use. So you can only add or subtract matrices with the same order. Okay, you do this by adding and subtracting their corresponding elements. Okay, so each element is in a position. We have learned that it's like the row, first column. Okay, that's an element. So if A is 1, 1 in let's say this matrix over here, that is A1, 1, and this will be A2, 1. All right. So if we add it to another matrix, which will be B1, 1 and B2, 1, they must be the same order. So the order here is a 2 rows by 1 column. This one is also a 2 rows by 1 column. Are they the same? Yes. If they are the same, we can add them or we can subtract them. Okay. So when we add or subtract them, we only look at the position of the elements. So it will be A1, 1, A1, 1, okay, A row 1, column 1, plus we can only add that with B row 1, column 1. That will give us an answer. I don't know what the answer is, C1, 1. Okay, that will give us an answer here that we don't know of. So this is what we mean by if you are adding the matrices or subtracting. This position must be added to the same position of the or element in the same position on the other matrix. And that is how we do it over here. So I just wanted to explain that writing down, but we will see now cool examples that we have as well. So that we can see that. So we have an example here. Let's add two matrices, matrix A and matrix B. And remember, I just rephrase again that we said matrices will have capitalized letters for names, almost like sets, right? Where we have capitalized letters to represent our sets, okay? So let's first look at matrix A. Matrix A is having 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, those are the elements here. Again, I will write down this is a, what is the order again? Is there somebody who can help me quickly with the order or the dimension of this matrix?
So 2 by 3.
2 by 3.
No, actually 3 by 3.
Yes, it's a 3 by 3. Okay. So this is important, guys. I told you for the exercises that we had, if you don't spend time on the order and the dimensions, well, you will not be able to answer any questions. Okay, so that's the first thing we need to do. We get the dimension or the order or how we call it, the size of the matrix or something like that. So this is a 3 by 3. So if I have to add or subtract it to something else, the other thing must also be a 3 by 3. If it's not, then this is not possible, okay? Unless you are doing some extra sophisticated level of mathematics that you come up with other things, other ways to try and add these things that are new to some of us scholars, then maybe you can prove to us that you can add or subtract matrices that are not of the same dimensions. So over here, you can see that we said that this will be a 3 by 3. And you can also see that this one is the same, except this is numbers, this is letters. So this is definitely also a 3 by 3. 3 rows, 1, 2, 3, 3 columns, 1, 2, 3. Okay, so that's how we know it's 3 by 3. We proceed. So let's add or subtract the two of them. I will just clear that so that we can see. So if we are asked to do A plus B, so that means this plus that one. So we will write down a bigger matrix because we need to show our working. So this is what we do. We start with the first element in the first row. All right, that is a 1 over here for A. We are adding it with this element in the same position of the second matrix of B. So that is 1 plus A. That will be what we will put in our new matrix that we formed called A plus B. We do that for the second one. The second column, first row, you can decide. You can either go row, all right, finish the first row, second row, third row, or you say finish the first column, second column, third column. In most cases, going row first, finish first row, finish second row, third row is always a good approach that will make sure that we have settled everything in that row. So we only need to focus on the other row. All right. So this will be 2 plus B. They are in the same positions. We do that again for C. That will be 3 plus C. And then we put it in the position. You can see that number 1, 1 plus A is in the position of where it came from. 2 plus B is in the position where it came from. 3 plus C is in the position where it came from. So the positioning is also very important. So we will do that for the next ones. That's 4 plus D. It goes into the position where it came from. 5 plus E, it goes into the position where it came from. 6 plus F, it goes into the position where it came from. 7 plus G in the position. 8 plus H into the position where it came from. And 9 plus I into the position where it came from. So I'm always putting an extra bigger brackets to do the calculations there. And after you have done these calculations, written it out in this way, we can have always a final matrix over here that we will now get the values. What is 1 plus A? Then you put the answer in here. And remember the rule that we said, if we are adding or subtracting, if you start with a 3 by 3, you will always end in a 3 by 3 also. All right, this is still a 3 by 3 because we have 1, 2, 3 rows. We still have 1, 2, 3 columns. So this is also a 3 by 3. Okay, so that is basically what we need to do. So I put algebra here and numbers here, and the rest of the things is basically just applying mathematics. You are adding, so you just add. If you are subtracting, we will just change the addition to subtraction, and that is basically what I have over here. We just change the sign. Since it says A minus B, then it's A minus B. One very important thing to mention is if A is the first matrix, then you must take the first element of A. You cannot now say A minus B is A minus 1. No, this is different because this will give you is B minus the matrix B minus A. Then you have A minus 1 because we will start with B and then subtract the element of A from that one. Okay, so just take note of this process here. So how you order and structure the things is also very important so that you don't lose marks. And I have seen in previous exams, a lot of students lose a lot of marks here. It's easy. You're just adding, you're just subtracting. But because we are lazy, we don't want to follow the rules and the steps one by one by one. You make a simple mistake somewhere and you lose the whole marks because then it's wrong. It's like, for me, it's like you are supposed to add. It's like this guy cannot even add this element with that element, 4 plus D. You cannot even add, or you cannot even subtract the correct element. Then it becomes a problem. We have also seen good practice for some students is when you add, you like make lines inside here. Remember, I told you don't put lines inside there. It's problematic. But if you are doing row by row, then I can see, okay, 1 here and the A there, I can put it in that position over there. So just to make sure that you are adding the correct stuff and not the wrong ones. Okay, that is very important. Other than that, that is it for adding and subtracting matrices, right? Just make sure the dimensions must be the same, okay? And your answer must still have the same dimensions as when you started, okay? And here we have examples of addition and subtraction, and we now make it more complicated for you guys. All right. So over here, we have, let's call this matrix C, we don't know what it is, we call this matrix D, and then we call this matrix F, okay? C, D, F, we don't know what they are, but we are just telling you. If matrix C has the elements A, 3, minus 1, B, plus matrix D, 4, C, D, minus 5, equals to 5, 5, okay? Quick question to anybody is, what type of matrix is this? Okay, the special name for this matrix. Is there anybody who remembers? Before we continue, just a quick bonus question. What type of matrix is this one over here?
Diagonal matrix.
Yes, this is a diagonal matrix. That is correct, Rishiwa. So if this is what we are giving you in the exam, all right? And remember, this is what I've told you before. In the class, we will teach you, this is how you add the matrix. In the exams, we ask you a question like this, okay? So we write it like this. Then we ask you, okay, find A, B, C, and D. Then you go like, but sir, you never taught us this. Okay. What do I say to that question? I did teach you matrix addition, right? And now I give you something like this, and I just took out some answers here, and then you go like, but sir, you never taught us this. And like, ish, how do I answer that question? And this is very common to a lot of topics in mathematics. So this is basically testing your knowledge. Do you understand what matrix addition is, or did you just look at the textbook and say, oh, you just add these two things and that is it? This is why it's important for us to basically have a teacher in front of you, because on YouTube videos or things like that, they will never explain these things. It's just also, oh, let's just solve this. This is the answer. And then your brain goes like, but I've never seen anything like this before in my life. So let's just break this down a little bit based on what we know. So we know that if we add these two matrix C plus D, okay, which will be equals to F, we know that we must add the elements in the positions, right? And then those elements in that positions will be the answer in F in that same position, okay? So in this case, we are saying if I add C, the element A, plus the element in the same position of D, which is 4, will give me the element in the same position of F, which is 5. Now, if I write it like this, A plus 4 equals to 5. Now, what is the answer of A? It becomes now easier to see, all right? So who can give us the answer of A?
A is 1.
A is 1, okay? So you can see now, because I broke it down like this, it became easier to understand. But if you look at it for the first time, just get the question like this, you go like, I've never been taught this thing in my whole life. It becomes a problem, all right? So this is part of mathematics where, especially from grade 11 and grade 12 people, we expect you to be able to manipulate whatever question you have to work to your advantage, all right? This over here is called a linear equation, right? Or linear algebra, linear equation, whatever we have. A plus 4 equals to 5. This is like the most basic thing for grade 8 level. They will be able to get this answer. Grade 8 question, this is what we give to grade 8. Grade 11, grade 12, university, this is what we give you over here. Same thing, just the way we put the question is where you can see the levels are different. And that is one thing that you have to know. Everything that you will get in your question paper are fairly simple. It's just the level of the question is for you guys. We expect you to be able to answer questions like that. So we write this as a linear equation because I know addition means just that element plus the same element position, and that is what we have. Also, a very good way to check is this is a 2 by 2, right? We are adding it to another 2 by 2, okay? And our answer is still 2 by 2. So it follows the rules that the dimensions must be the same, all right? That's just what we have noticed. So here, that is what we did. We look at that. That's the A plus the 4, which equals to the 5. We look at the second element again. That's the 3 plus the C equals to 0. We look at the fourth element, the next position element there. That's the -1 plus the D equals to 0. And then we look at the other element over there. That's the B. Now it's here. I say B minus 5. If you notice, remember that we said anything with a plus minus. If you get plus minus together, it just results in a minus, right? A positive and a negative gives you a minus, all right? So that is what we have. We can have also changed this to be B plus minus 5 in brackets, and that will be equals to 5, okay? So we could have also written it like this, but then you can see now I have a plus bracket minus. This is a common thing that you will find a lot, especially in grade 11 questions in grade 11 level. You will always see that thing over there. And once it's over here, Napume, I can see you are writing. You can please, yes, if you can write, Napume, please give us the answers for A, B, C, and D. Since I know now you can write, please proceed for us just to give us the answers. Almost grade 8 word now. Napu. The rest of you can type in the chat if you want to finish the answers so that we also know we are working. It'd be nice to have you write on the board. I know students like to write on the board. Okay, I have A1. Okay, we already have the A is 1. Napu, you can write. I think your friends are also giving you answers over here. Hey, Napu, are you using a phone? C, C, B. Okay. And D is missing. Okay, so all the answers are given in the chat, but Napu writing is missing there. So the writing was missing there. Are you going to write, Napu? Okay, maybe we lost connection. All right, so basically that is correct for everybody who attempted it. So you can see it's okay. We can see it's easy if we write it like this, but we will not make it, I'm talking about this now. It's easy if we write it like this, but we will not make it that easy for a grade 11 learner. You are not in grade 11 to do these simple things, all right? That is important for you to note. We are not going to be doing these simple things just like that. We're not giving you 3 marks just like that. And I keep arguing with some of my colleagues who are also teaching grade 10s to do these things. I said, people, you must teach them complicated things already in the beginning so that when these things come up, your brain immediately sees and identifies that, oh, it's easy, okay? And we don't have to always answer that way. Okay, there is, sorry, there is B, which is supposed to be, sorry, B, I made a mistake with B is supposed to be not -10, but 10, okay? That's just from my side, that it's supposed to be +10. So +10 minus 5 equals to 10, yes. So let's proceed to the next one. So we also have equal matrices, and equal matrices is now another thing that we will talk about. So for matrices to be equal, all the elements in A must be equals to all the elements in B. And we say two matrices A Aij and Bij are said to be equal if they are of the same order or dimension or size. They are first the same order, dimension of size. Secondly, each element in A is equal to the corresponding element in B. So the element here, the first element of A is the same as the first element of B. They must be the same also, all right? For example, we have a matrix over here. We have matrix A, the previous one we have 5, 6, 7, minus 2, 1, and 0. And this is a 2 by 3. And we can say it's equals to matrix B, 5, 6, 7, minus 2, minus 1, and 0. So all the elements here in A are also in B. And all the positions of the elements in A are also in the positions of B. It's the same positions for each one of them. Then this matrix, because 5 is equals to 5, 6 is equals to 6, 7 is equal to 7, and you can see for the rest of them. For this reason, matrix A is equals to matrix B, or A equals to B, all right? Over here, we have another example of something that we have over here. And we can see that even though this is a 2 by 3 matrix, this 5 and 15 is not the same. So this means that A is not equal, matrix A is not equals to matrix C. And we also write it like equal to scratched out. But we can say that 3A, okay? So if you say A times 3, then it will be equals to C, all right? So this is just an extra thing to note that if I put a 3 in front of the A here, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times minus 2 is minus 6, 3 times minus 1 is minus 3, 3 times 0 is 0. So 3A is equals to C. That is another observation that we can make. And sometimes we ask trick questions like this. Maybe we give you matrix A and matrix C, and we say, how can matrix A be equal to matrix C? Then you have to now figure out, okay, I need to do this and this and this there, all right? So that's just one of the questions that may pop up later on. All right, guys, I think we will stop there because this will be the next next lesson that will be on Monday. It's a lot of explanations. That's why it must be a fresh lesson on its own. We will not be talking about matrix multiplication now, very confusing. For now, let us digest matrix addition, matrix subtraction, matrix scalar multiplication, all right? So let me just end the show quickly here. And I want to go to the questions that we have put up for you guys for homework. So the questions are basic operations for matrices. This is the questions that we will expect you to answer. And we have said that we will answer them as follows. On a piece of paper, it can be in your exercise book, all right? Matrix operations, basic operations, addition, subtraction, and scalar multiplication. That is what you need to do, all right? So also look at the question here. It says simplify. So simplify just means make it simple. Add it, subtract it, write undefined for expressions or matrices that are undefined. That if you cannot add it, if you cannot multiply it, just write undefined. Now this undefined is also very important. A lot of us, we are given questions and then you realize that I cannot do anything with this question. And then you think there is a problem with the question. There is no problem with the question. You just write equals to undefined or equals to cannot solve or cannot be solved, something like that. That is also an answer. You get an answer for that. If you write undefined, you get your full marks. If the marks was probably like 3 or 4. This is testing understanding. We are not just testing. Can you add things? Can you subtract things? That is not on your level. Please understand. Your level is, do you understand what you are doing? Yes, I understand what I'm doing. This I cannot solve. That is undefined. Correct. Full marks. So a lot of exams, there are questions that learners, students, they don't understand the thing. And because they don't understand the thing, you skip the question. If you leave it blank, it is wrong. Okay? I'm stressing that one out. Do not leave anything blank, okay? Rather write something, and from that something, you get your marks. If there's nothing, you get nothing marks. If there's something, you get something marks, okay? I hope that is very clear, all right? Okay, the first one is not undefined. It's a never leave wrong answers on the board. Okay, so this is basically what we want you to attempt. So you can either answer on the paper and then upload it back on the Google Classroom as well. I will just show you quickly again for those who joined us now what we expect you to do. So you can download it. It is available on Google Classroom, but let me just quickly go through. So you have about 24 questions. 1, 2. You can see this one is addition. This one is subtraction. This one is scalar, scalar, addition, scalar, 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 addition, scalar, addition, 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 interesting addition, okay, to find out. Scalars, scalar, scalar, subtraction, addition, addition, subtraction, scalar, and addition. Subtraction, subtraction, addition, scalar, something like that. So you have to figure it out as well. So let me just quickly show you where you can find the material, and we can see. So in our classroom, you will notice it's already available under classwork. I've put the topic matrices separate now so that you can see what we have posted. That was the first homework. This is now the second homework. The PDF is the question, or the questions that you have just seen me explain now. It's exactly the same. So this is where you can find the questions. And if you have those apps that I told you before that you can use, then you can use the app Adobe Scan, Adobe PDF Reader to answer the questions on here. If you don't have them, answer on a piece of paper. You just write number 1, what is the answer? Number 2, what is the answers? And so forth. And then once you have done number 1, number 2, what is the answers? Then let me just quickly show you here. This is just how I also test everything if you are using a phone, so that I know whatever I give to my students, whether you have a phone, you can still do your education, you can still learn. If I don't have a phone, if you don't have a phone or anything like that, then I would at least know, okay, it's not possible. What I'm giving to the students is not possible. So once you get this and you write it down on a piece of paper or answer on the paper, then please, this is the part where you have to upload, okay? So you have this Google form where you have to upload your answers. You write your name, your surname, your grade, and it says here, add a file, okay? So add a file is selecting where you have now saved it on your device, and that's where you will upload your file, either as a picture or PDF or Word document. Or a picture is now if you write on the paper and you snap it and then you upload it, and then it will show you. This will disappear if you have uploaded it correctly. Then you must click on submit over here at the bottom. So submit, then that means it will go through. All right. I just wanted to show you the apps that you need. Adobe Scan, if you are using pen and paper, Adobe Scan will help you to upload it. Adobe PDF will also help you to view and edit the PDF if you have Adobe PDF. You can also now just write it down. I think Loida is using Adobe PDF. By clicking on this edit button, you can add a comment, and the comment has a sort of a pen. And with the pen, you can now write there 3x plus 4, or anything that you want to do on your